There are several approved methods for measuring current without opening electrical panels, addressing safety concerns when working with high-voltage systems. These methods primarily involve non-contact current sensors, insulated clamp-on current transformers, and remote current transformers. Firstly, non-contact current sensors offer a safe way to measure current by detecting magnetic fields without direct electrical contact. Hall effect sensors are one type, attaching to the outside of the insulation or motor power lines and detecting the magnetic fields generated by the current flow. Secondly, Rogowski coils are flexible coils that wrap around the current-carrying conductor. They generate a voltage proportional to the current flowing through them. These sensors avoid direct electrical contact with the conductors. Thirdly, insulated clamp-on current transformers, also known as CT, provide electrical isolation. Flex CT are a specific type with a split core that closes around the current-carrying conductor. These are available in various sizes to accommodate different conductor diameters. Fourthly, window CT are similar to flex CT but have a removable window for easy installation around existing conductors. These designs allow installation without disconnecting or interrupting the power supply. Fifthly, remote CT offer options for monitoring current from a distance, further enhancing safety. Wireless CT transmit current measurements wirelessly to a receiver, enabling remote monitoring without direct connection to the panel. Sixthly, Ethernet CT connect to an Ethernet network and transmit data to a monitoring system over Internet Protocol, or IP, facilitating centralized data collection and analysis. Regardless of the method chosen, adherence to approved practices is crucial. Ensure that the selected method meets the relevant electrical safety standards, such as International Electrotechnical Commission, or IC, Standard 61010, or National Fire Protection Association, or NFPA, Standard 70. Verify the accuracy and reliability of the measurement system to ensure that the data collected is dependable. Follow all manufacturer's instructions for safe installation and use to prevent accidents and ensure proper functioning of the equipment. Wear appropriate personal protective equipment, or PPE, which may include gloves, eye protection, and flame-resistant clothing, depending on the voltage and potential hazards. Familiarize yourself with proper electrical safety procedures, including lockout-tagout procedures and arc flash safety protocols. Even with approved methods, it is recommended to proceed with caution when working with high-voltage systems. Consider using remote monitoring systems to minimize potential safety risks by reducing the need for personnel to be in close proximity to energized equipment. Before selecting a method, consider the specific requirements of the application, including the current range, conductor size, and desired level of accuracy. Research the available options and choose a system that is appropriate for the environment and meets the safety requirements. Regularly inspect and maintain the current measurement system to ensure its continued accuracy and reliability. Replace any damaged or worn components promptly. Document all procedures and measurements to maintain a record of the monitoring activities. This documentation can be helpful for troubleshooting and future analysis. When using clamp-on CT, ensure that the jaws are clean and free of debris to maintain proper contact with the conductor. Avoid using clamp-on CT on conductors that are heavily insulated, as this can affect the accuracy of the measurement. If working in a hazardous location, such as an area with flammable gases or dust, ensure that the current measurement system is rated for use in such environment. Ground the current measurement system properly to prevent electrical shock hazards. Use a calibrated multimeter to verify the accuracy of the current measurements. If the measurements are not accurate, troubleshoot the system to identify and correct the problem. Consider using a data logger to record current measurements over time. This data can be helpful for identifying trends and anomalies. Before installing or using any current measurement system, consult with a qualified electrical engineer or technician. They can provide guidance on selecting the appropriate system and ensuring its safe and proper installation. Obtain necessary permits and approvals before performing any electrical work. This may include obtaining permits from the local building department or electrical utility. Coordinate with other trades and personnel to ensure that the work is performed safely and efficiently. This may include coordinating with mechanical, plumbing, and fire protection contractors. Use appropriate tools and equipment for the task. This may include using insulated tools, voltage testers, and personal protective equipment. Follow lockout-tagout procedures to de-energize the electrical circuit before working on it. This will help to prevent electrical shock hazards. Inspect the electrical circuit for any signs of damage or wear. This may include checking for frayed wires, loose connections, and corroded components. Repair or replace any damaged components before energizing the circuit. Use a voltage tester to verify that the circuit is de-energized before working on it. This will help to prevent electrical shock hazards. Work in a well-lit and ventilated area. This will help to improve visibility and reduce the risk of exposure to hazardous materials. Keep the work area clean and organized. This will help to prevent accidents and ensure that the work is performed efficiently. Dispose of waste materials properly. This may include disposing of hazardous materials in accordance with local regulations. Document all work performed. This documentation can be helpful for troubleshooting and future maintenance. After completing the work, test the electrical circuit to ensure that it is functioning properly. This may include checking the voltage, current, and resistance of the circuit. Follow all applicable codes and standards. This may include the National Electrical Code, or NEC, and other applicable codes and standards. Seek professional assistance if you are not comfortable performing electrical work. This will help to ensure that the work is performed safely and properly. When using wireless CT, ensure that the wireless signal is strong and reliable. A weak or unreliable signal can lead to inaccurate measurements. Consider using a signal booster to improve the wireless signal strength. When using Ethernet CT, ensure that the Ethernet network is secure and reliable. A compromised or unreliable network can lead to data loss or unauthorized access. Consider using a virtual private network, or VPN, to secure the Ethernet network. Regularly back up the data from the current measurement system. This will help to prevent data loss in the event of a system failure. Store the data in a secure location. This will help to protect the data from unauthorized access. Review the data regularly to identify any trends or anomalies. This can help to identify potential problems before they become serious. Use the data to optimize the performance of the electrical system. This can help to improve efficiency and reduce energy consumption. Share the data with other stakeholders, such as plant managers and maintenance personnel. This can help to improve collaboration and decision-making. Conduct regular training for personnel on the safe operation and maintenance of current measurement systems. This will help to ensure that personnel are aware of the potential hazards and how to mitigate them. Keep abreast of the latest developments in current measurement technology. This will help to ensure that the system is using the best available technology. Implement a comprehensive safety program for electrical work. This program should include procedures for hazard identification, risk assessment, and control measures. Conduct regular audits of the safety program to ensure that it is effective. The use of appropriate current measurement techniques is essential for ensuring the safe and efficient operation of electrical systems. By following these guidelines, you can minimize the risks associated with electrical work and improve the reliability of the system. When choosing a current measurement method, consider the long-term costs of ownership. Some methods may have lower initial costs but higher maintenance costs. Other methods may have higher initial costs but lower maintenance costs. Choose the method that is most cost-effective over the long term. Consider the environmental impact of the current measurement method. Some methods may use hazardous materials or generate waste. Other methods may be more environmentally friendly. Choose the method that has the least environmental impact. Consider the ease of use of the current measurement method. Some methods may be easier to use than others. Choose the method that is easiest for personnel to use. Consider the availability of technical support for the current measurement method. Some manufacturers may offer better technical support than others. Choose a manufacturer that offers good technical support. Consider the reputation of the manufacturer of the current measurement method. Some manufacturers may have better reputations than others. Choose a manufacturer with a good reputation. Before purchasing a current measurement system, obtain quotes from multiple vendors. Compare the quotes carefully to ensure that you are getting the best possible price. Negotiate the price with the vendor. You may be able to get a low price by negotiating. Read the fine print of the contract carefully before signing it. Make sure you understand the terms and conditions of the contract. Get the contract reviewed by an attorney before signing it. This will help to ensure that the contract is fair and protects interests. When installing a current measurement system, follow the manufacturer's instructions carefully. This will help to ensure that the system is installed properly and functions correctly. Use qualified personnel to install the current measurement system. This will help to ensure that the system is installed safely and properly. Inspect the installation carefully to ensure that it is done correctly. Correct any deficiencies before energizing the system. Test the system thoroughly after installation to ensure that it is functioning properly. Document the installation carefully. This documentation can be helpful for troubleshooting and future maintenance. Keep the current measurement system clean and free of debris. This will help to ensure that it functions properly. Inspect the system regularly for any signs of damage or wear. Repair or replace any damaged components promptly. Calibrate the system regularly to ensure that it is accurate. Maintain a record of all maintenance and repairs. This record can be helpful for troubleshooting and future maintenance. Train personnel on the proper operation and maintenance of the system. This will help to ensure that the system is operated safely and properly. Develop a written maintenance plan for the system. This plan should include procedures for inspecting, cleaning, calibrating, and repairing the system. Review the maintenance plan regularly and update it as needed. Follow the maintenance plan carefully. This will help to ensure that the system is properly maintained and functions correctly. Keep a supply of spare parts on hand. This will help to minimize downtime in the event of a system failure. Contact the manufacturer or a qualified service technician for assistance with any problems. Do not attempt to repair the system yourself unless you are qualified to do so. Follow all safety precautions when working on the system. This will help to prevent electrical shock hazards. Wear appropriate personal protective equipment, or PPE, when working on the system. This may include gloves, eye protection, and hearing protection. Work in a well-lit and ventilated area. Keep the work area clean and organized. Use appropriate tools and equipment for the task. Dispose of waste materials properly. Document all work performed. After completing the work, test the system to ensure that it is functioning properly. Follow all applicable codes and standards. Seek professional assistance if not comfortable performing maintenance on the system.